So here we have the function sine cube t. So we need to determine the Laplace transform of the given function. Now, since it's a sine cubed of t, we are going to use the identity sine 3t is equals to 3 times sine t minus 4 times sine cubed t. Now, when we solve for sine cubed t, so we have sine cube of t, so that will be equals to 3 sine of t minus sine 3t divided by 4. So the entire purpose of doing this transformation is because we want to change the power of sine function to 1, from 3 to 1. So that means the f of t can be rewritten as 1 over 4 multiplied to 3 times sine of t minus sine of 3t. Now let us apply the Laplace transform. So Laplace transform of f of t will be equals to 1 over 4 times 3 times Laplace transform of sine t minus Laplace transform of sine 3t. So here we have used the property of linearity of the Laplace transform. So we have 1 over 4 multiplied to 3 times the Laplace transform of the sine function is 1 divided by s squared plus 1 squared minus Laplace transform of sine 3t will be 3 divided by s squared plus 3 squared. So we have 1 over 4 multiplied to 3 times s squared plus 1 minus 3 divided by s squared plus 9. Now we are going to combine the two terms. So before that we are going to pull out 3 from both the numerators. So we have 3 over 4. Now combining the two terms in the numerator, so we have s squared plus 1 multiplied to s squared plus 9, and in the numerator we're going to have s squared plus 9 minus s squared minus 1. So s squared and s squared gets cancelled, so we have 3 over 4 multiplied to 9 minus 1, so that's 8 in the numerator, divided by s squared plus 1 multiplied to s squared plus 9. So 4 times 2 is 8, so therefore we get 3 times 2, which is 6. So we have 6 divided by s squared plus 1 multiplied to s squared plus 9. So this is the Laplace transform of sine cube t, and it's going to be valid for s greater than 0. Let us do another problem. So we have the function cosine cube t. So before finding the Laplace transform, we're going to change the given function by using the identity cosine 3t is equals to 4 times cosine cube t minus of 3 times cosine t. Now if we arrange the terms, so we have cosine cube of t is equals to cosine of 3t plus 3 times cosine of t whole divided by 4. So we have 1 over 4 multiplied to cosine 3t plus 3 times cosine of t. Now let us try to find out the Laplace transform of our function cosine cube t. So that will be equivalent to finding the Laplace transform of 1/4 of the Laplace transform of cosine of 3t plus 3 times the Laplace transform of cosine of t. which will be equals to 1 over 4 multiplied to Laplace transform of cosine of 3t will be s divided by s squared plus 3 squared, so that's 9, plus 3 times 1 over s squared plus 1 squared, so that is 1. So this is the Laplace transform of the cosine function, cosine of t. So that gives us s over 4 times of s squared plus 9 plus 3 divided by 4 times s squared plus 1. So this is the Laplace transform of our function cosine cubed t, and it's going to be valid for all values of s greater than 0. Let us move on to the next problem. So here we have the function sine cube of t times cosine cube of t. So this can be rewritten as sine t times cosine t whole cubed. Now we're going to multiply and divide by 2. So we have half multiplied to 2 times sine t times cosine of t whole cubed. Now this has been done because this is an identity which is sine of 2t. So we have half sine of 2t whole raised to the power of 3. So we get 1 over 8, which is half raised to the power of 3 will be 1 over 8 times sine cube 2t. Now we also know that sine cube of t is equals to 3 sine t minus 4 sine cubed t. This is sine 3t. Sine 3t is equals to 3 sine t minus 4 sine cubed t. Now, if we replace t by 2t, so then we're going to get sine 6t equals to 3 sine 2t minus 4 sine cubed 2t. Now we're going to write the identity in terms of sine cube of 2t, so that gives us sine cube of 2t, so that will be equals to 3 sine 2t minus sine 6t divided by 4. So so instead of sine cube of 2t, we replace it with this particular identity. So we're going to get 1 over 8. So 8 times 4 will be 32 multiplied to 3 times sine 2t minus sine 6t. So now we'll find out the Laplace transform of this particular function. So Laplace transform will be 1 over 32 times 3 times the Laplace transform of sine 2t minus Laplace transform of sine 6t. So that gives us 1 over 32 multiplied to 3 times, so Laplace transform of sine 2t will be 2 divided by s squared plus 2 squared, so that is 4, minus Laplace transform of sine 6t will be 6 divided by s squared plus 6 squared, so that is 36. So we have 1 over 32, 3 times 2 is 6 divided by s squared plus 4 minus 6 divided by s squared plus 36. Now we can take 6 as a common term from the numerator of both the two terms. So that will give us 6 over 32. We have 1 over s squared plus 4 minus 1 over s squared plus 36. So we're going to combine the two terms. So that gives us 6 over 32 will be 3 over 16 times s squared plus 4 times s squared plus 36. So in the numerator we have s squared plus 36 minus s squared minus 4. So the s squared and negative s squared gets cancelled, and we have 3 over 16 multiplied to 36 minus 4, so that will be 32 divided by s squared plus 4 times s squared plus 36. Now we know that 6 times 2 is 32, and that finally gives us 3 times 2, which will be 6 in the numerator, divided by s squared plus 4 times s squared plus 36. So this is the Laplace transform of our function sine cube of t times cosine cube of t, and this is going to exist for all values of s greater than 0. Let us do another problem. So here we have the function sine raised to the power of 4t. So we can rewrite this given function as sine squared t whole raised to the power of 2. Now this has been done because we know that sine squared t can be written as 1 minus cosine of 2t divided by 2 whole squared. Now we're going to expand it, so that it's going to give us 1 over 4. So we have 1 squared, so that will be 1 plus cosine squared 2t. So we have cosine squared 2t minus 2 times 1 times cosine of 2t. So that will be simply 2 times cosine of 2t. Now we can again change cosine squared of 2t by the identity 1 plus cosine of, since this is 2t, so that will be double of it, so that will be 4t divided by 2 minus of 2 times cosine of 2t. So this is going to give us 1 over 8 multiplied to 2 plus 1 plus cosine of 4t minus 4 times cosine of 2t. So we have 1 over 8 multiplied to 3 plus cosine of 4t minus 4 times cosine of 2t. So now we're going to apply the Laplace transform to this particular function. So we get 1 over 8 multiplied to 3 times the Laplace transform of 1 plus Laplace transform of cosine of 4t minus 4 times the Laplace transform of cosine of 2t. So that gives us 1 over 8 multiplied to 3 times Laplace transform of 1 is 1 over s, so we have 3 over s, plus Laplace transform of cosine of 4t will be s divided by s squared plus 4 squared, so 4 squared is 16, minus 4s divided by s squared plus 2 squared, so 2 squared is 4. So this is the Laplace transform of our given function, and this is going to be valid for all values of s greater than 0. Let us do another problem. So here we have the function the fourth power of cosine of t. So this can be written as cosine squared t whole squared, so that we can substitute the value of cosine square of t by 1 plus cosine 2t whole divided by 2 whole squared. So that gives us 1 over 4 times 1 plus cosine of 2t whole squared. So that will be 1 plus 2 times cosine of 2t plus cosine squared of 2t, which will be equals to 1 over 4 multiplied to 1 plus 2 times cosine of 2t plus, now cosine squared of 2t can be rewritten as 1 plus cosine of 2 times of 2t, so that will be 4t divided by 2. Well, so we can say 1 over 8 multiplied to 2 plus 4 times cosine of 2t plus 1 plus cosine of 4t. So 2 plus 1, that's going to add up and give us 3. So we have 1 over 8 multiplied to 3 plus 4 times cosine of 2t plus cosine of 4t. So this is the function f of t, which is cosine of 4, the fourth power of cosine of t. So we're going to find the Laplace transform. So Laplace transform of our function will be equals to 1 over 8 multiplied to Laplace transform of 3 times the Laplace transform of 1 plus 4 times the Laplace transform of cosine of 2t plus Laplace transform of cosine 4t. So that gives us 1 over 8 multiplied to 3 times the Laplace transform of 1 as 3 over s plus 4 times the Laplace transform of cosine of 2t, so that will be 4s divided by s squared plus 2 squared, so 2 squared is 4, plus Laplace transform of cosine of 4t, so that will be s divided by s squared plus 4 squared, so that is 16. So this is the required Laplace transform, and this is going to be valid for all values of s greater than 0. So here we have the function sine of t raised to the power of 4 times cosine of t raised to the power of 4. Now we are going to rewrite this particular function as sine of t times cosine of t whole raised to the power of 4. Then we're going to multiply and divide by 2. So that gives us 1 over 2 times 2 times sine of t. Cosine of t will be sine 2t whole raised to the power of 4. So we are half raised to the power of 4, so that will be 1 over 16 times sine 2t raised to the power of 4. So this can be rewritten as 1 over 16 sine squared 2t whole squared. Now sine squared 2t can be rewritten as 1 over 16. So we have 1 minus cosine of 2 times of 2t, so that will be 4t divided by 2 whole square. So we have 1 over 16 times 2 squared, so that is 4, multiplied to 1 minus cosine of 4t whole square. So that gives us 1 over 64, and 1 minus cosine of 4t whole squared will be 1 minus 2 times cosine of 4t plus cosine squared 4t. Now we can again change cosine squared 4t, so we have 1 over 64 multiplied to 1 minus 2 times cosine of 4t. So the first two terms remains unchanged. This third term will become 1 plus cosine of 2 times of 4t, so that will be 8t whole divided by 2. So we get 1 over 64 times 2, so that will be 128 divided multiplied to 2 minus 4 times cosine of 4t plus 1 plus cosine of 8t. So we have 1 over 128 multiplied to 3 minus 4 times cosine of 4t plus cosine of 8t. So this is the function f of t, which is sine t raised to the power of 4 times cosine t raised to the power of 4. Now we're going to find the Laplace transform of the given function. So Laplace transform of our function f of t will be equals to 1 over 128 multiplied to 3 times Laplace transform of 1 minus 4 times the Laplace transform of cosine 4t plus Laplace transform of cosine of 8t. So we have 1 over 128 multiplied to 3 times the Laplace transform of 1, so that will be 3 over s minus 4 times the Laplace transform of cosine of 4t will be s divided by s squared plus 4 squared, so that is 16, plus Laplace transform of cosine of 8t, so that will be s divided by s squared plus 8 squared, so 8 squared is 64. So this is the Laplace transform of a given function, and it is going to exist for all values of s greater than 0.